Today we're going to switch back and forth from rectangular and polar. And since you kind of have an idea how this works, the formulas we're going to use are at the top, but the equations we're going to solve for are complicated, at least by comparison to just r equals and theta equals. Kind of the trick to this one is I'm going to throw another one up here. If we take a look at this one right here, this r equals the square root of x squared plus y squared. If you square both sides, you get r squared equals x squared plus y squared. Sometimes having a radical sign in your problem is not always good. Sometimes it's hard to deal with. So if you can avoid that, I would suggest it. If you don't care about it, then keep it in there. I'm going to kind of work around it and try not to have it. So we already know this, r equals 10. We know that's a circle, a radius of 10. We know that the center is at 0, 0. But to show you my trick with r squared, I wanted to show you with one that was simple. So you already know the answer to this. But if you square both sides, we get r squared equals 100. And now if we use this fancy r squared formula, so if we take out the r squared and put in x squared plus y squared, then you don't have to think so much about, oh, where's the center, what's happening. So that's the way I would do that one. We know how to do this one already. We're going to take the tangent of both sides. I just didn't want to, I wanted to start at the beginning. So this really is the beginning. So the tangent is always y over x. The tangent of 135 is negative 1. I'm going to throw that over 1 and cross multiply. So we get y equals negative x, which maybe you knew that already from where the 135 is located. So let's take this up to the next thing here. Cosecant. We don't have anything that has cosecant in it, so we're going to have to change this to 8 over sine theta. So we're going to have to shove that into the denominator. Now we're going to cross multiply. So we'd get r sine theta equals 8. Oh, I think I skipped a step. Oh, nope, sorry. I was thinking about something else. All right, so then r sine theta, we know r sine theta right here. R sine theta is y. So y equals 8. Pretty simple. All right, so this one looks a little bit crazier. We can just go ahead and cross multiply. If you go one direction, you get a 2, and the other direction you have r times 3 cosine theta minus 6 sine theta. If you distribute the r, you get 2 equals 3r cosine theta minus 6r sine theta. And we already know that this and this are parts of our formula. So r cosine theta is really x, r sine theta is really y. So now we have 2 equals 3x minus 6y. Remember, we're going to rectangular. We want to get rid of the r and the theta and the sine and the cosine. We've got to get rid of all that. We only want x, y, and numbers. Of course, we can have powers. You can have powers, and you can have fractions, but that's really all we want. This is obviously a line, and when you have a line, you solve for y. So 2 minus 3x equals negative 6y. I'm going to divide everything by negative 6, and we get negative 1/3 plus 1/2 x is equal to y. So there's your line, you have your slope, your y-intercept. You could graph that if you had to. So here's a little tip, just like we multiplied or both sides, or squared both sides in problem number 1. Sometimes we have to multiply both sides by r. And you'll recognize this because we want it to be, for example, 10r sine theta. There's no r there. There's no r on the right-hand side. If we had an r on the right-hand side, that's how we could get x and y. So if you multiply the right-hand side by r, obviously you have to multiply the left-hand side by r. So now we get r squared equals negative 24r cosine theta minus 10r sine theta. I try to write it in the order like that because that's how the formula is. R cosine theta is x, r sine theta is y. But we have r squared. Oh, r squared, we know what that is. That's x squared plus y squared equals negative 24x minus 10y. Take a look at this, x squared plus y squared, and that's a circle. And when we have a circle, sometimes we have to complete the square. So get all the x's together by adding this to the other side, We know we're going to complete the square. And then we have y squared. Add that 10y over. We know we're going to complete the square. Now this thing equals 0, but we are going to add two things to it. Half of 24 is 12. 12 squared is 144. Add that to both sides. Half of 10 is 5. 5 squared is 25. Add that to both sides. And now we can write the equation of the circle. Letter, first sign, number u squared. Letter, first sign, number u squared. And of course, add this up over here, we get 169. Here's your circle equation. This one's going to be the same. I know I went through that fast. Press pause if it's too fast, I guess. So we're going to multiply both sides by r. And we get r squared equals 16r cosine theta minus 30r sine theta. We know exactly what's going to happen. And we get rid of the r's, the sines, the cosines, everything. Get this set up for completing the square. So we have a negative 16x. And then we have y squared plus 30y. And then on this side, we're just going to have those two blanks. No need to write the 0, I guess. Half of 16 is 8. 8 squared is 64. Half of 30 is 15. 15 squared is 225. Letter, first sign, number u squared. Letter, first sign, number u squared. And over here we get 289. Remember, we really don't care what the circle equals as long as it's not negative. It could be a fraction, it could be a perfect square. It doesn't matter. Now we're going to go the other way. All right, our formulas are y equals r sine theta. I don't know why I started with y, sorry. And x equals r cosine theta. If we square both sides here, we get x squared equals r squared cosine squared theta. You don't square the angle. I don't know if you remember that from way long ago. So for y squared, since I know how to square x, I'm going to be able to square y also. So if we square this, right, if we square this guy right here, we square all of this. So we'd get r squared sine squared theta equals 2 times x, which is r cosine theta. Now we are trying to get this thing to be r equals. We have too many r's. We only want one. So we're going to divide both sides by r. Now we have r sine squared theta equals 2 cosine theta. Divide both sides by sine squared. And now you have to bring back all your trig. We have 2 cosine, and the bottom is sine times sine. And I purposely wrote it like that to show you. So we have this, and then we have this. So we get r equals 2 cotangent, because that's cosine over sine. 1 over sine is cosecant. Dust off that knowledge, bring it back out. Now we're going to go backwards to a line. We kind of already know what this looks like. This was one that we did yesterday. It has like a weird fraction with sine and cosine in it. Maybe you don't remember. We'll just go through it. So we're going to have 4r cosine theta plus 5r, sine theta. Now both of these have an r, so we have to factor that out because we're trying to get r written one time. Now we're going to have to divide both sides by that entire quantity. So if you can imagine, that whole quantity is here and here. Just ran out of space. So that's going to be gone over here. So we're going to end up with r equals 3 over 4 cosine theta plus 5 sine theta. We solve for r, so we're done. Super tricky one here. 2x squared. Well, there's no 2 in our formulas, right? There's a y, there's an x, we can square them, but how do you get the 2? The trick is to think of 2x squared as x squared plus x squared. Yep, if we had 3x squared, you'd call that, write it 3 times. And then we have plus y squared plus 3y equals 0. Right here. There it is. X squared, that's r squared, and 3y. So x squared, that means we can square everything. R squared, cosine squared, theta, plus another r squared, plus 3 r sine theta equals 0. Well, they all have an r in common. Well, actually, let's take a look at this a little bit better, a little different view. This is the only one that doesn't have r squared. So let's put him on the other side. R squared cosine squared theta plus r squared equals negative 3r sine theta. Because what I'm thinking is we can factor out this r squared, which is a little bit faster than just trying to do this one at a time. So if you factor out the r squared, don't forget the plus 1. And then over here we have negative 3r sine theta still. But you know we can do divide by r. So the r's gone here. So now we just have r cosine squared theta plus 1 in parentheses equals negative 3 sine theta. And you just divide by this whole quantity. So we get r equals negative 3 sine theta over cosine squared plus 1. Now every day we kind of do one graph at the end, and then this graph turns out to be what we do the next day. So no difference here. If you take a look at our equation, we have 4 sine 3 theta. So throw that in the calculator and let's get some values. What we are interested in is where everything is equal to 4. This coefficient is important. So we're looking for all the angles that equal 4. That's a 30. If you scroll down, that's 90 is negative 4. 150 is 4. Oops, that's not a 5, that's a 4. And that's it. We just have those 3 places. Okay. So let's take a look at that. So 34, 90 is negative 4, so that means it shoots away from 90. And 150 is also 4. I'm trying to show you how to be, these are kind of very tedious to graph. So I'm trying to show you how to be kind of good use of your time. So we have zeros at 0, we have a 0 at 60, we have a 0 at 120, we have a 0 at 180. All that means is we know that 0, 0 is in the graph. All those points are exactly the same. Any angle in 0 is your origin. But this is not what the graph looks like, right? It looks like a little flower. I'm hoping you looked at it. So let's look for the other numbers. So at 15, we have 2.8. And at 45, we have 2.8. This is all you need for the pattern. I would find a pattern and copy the pattern. It's way too tedious to plot all these points. So 15, 2.8. 45, 2.8. So what that shows me is one line on either side of the 4 is at 2.8. So I'm just going to use that pattern. I know what the answer is. You can see it on the calculator. And I don't know if you watch the calculator draw it or not, but it's pretty neat. I'm going to draw it for you here. So watch this. It starts there, goes like this, comes down, goes back up, like that. Now you don't have to draw it like that. Obviously you can just draw each petal. That's what we call these. You can draw each petal at one at a time. But it's very important that the length of each petal land on the correct angle, and that you plot each petal, that you don't just draw it in there. So make sure that the width is right and the length of each petal is accurate.